Hey everybody, it's Grant, the founder of KartFab.com, and today I'm going to show you how to build a go-kart engine, or how to modify the existing engine you have to get more torque, higher RPMs, make your go-kart faster, whatever. Now, it's important to remember that when you do performance modifications to an engine, it's the combined effect, not just one, that will make it really, really fast. And there are so many different combinations out there. This is my personal build that has high torque and does not have a super high red line or super high max target RPM to retain the low end torque that I need for this go-kart. So keep that in mind. Your own personal build will have probably different parts in it, but the general concept is the same. And the things we're going to go over here include block preparation and honing, head gasket install, setting the timing with a timing light, finding top dead center on the small engine without removing the head, throttle linkage, custom exhaust welding, frame modifications, troubleshooting an engine, setting valve lash, headlight installation, functioning brake light installation, throttle cable installation, tachometer installation, break-in procedures, as well as riding it around and having a good time. So let's go check it out.
All right, so here's what we got. Got the whole engine torn down, flywheel off, crank out, it's all hanging out over here. So if you look here in the cylinder, there isn't that much of a crosshatch pattern left in it. So what I've got here is called the flex hone, also called a ball hone. Some people call them a dingleberry. What it does is you stick it on your drill over here, right on the end, okay? Make sure it's lubricated with 10W30 oil. Then you put it in the bore as it's spinning and put it in and out. The stroke should be about 60 to 120 per minute, so that's relatively quickly. And your RPMs on your drill should be set low enough. You should do it by hand to where it's between maybe 5 and 800 RPMs. You don't want to do it any faster than that. So we went this way, clockwise, now we're going to go counterclockwise, okay?
So that's pretty much how you hone your bore. My engine bore was a little bit worn out, that's why I had to hone it. You're looking for a crosshatch pattern of about 45 degrees like you see here, so you can seat the rings when you install new rings.
Alright, so I made a little progress here. I got the crank in, got the oil clearance checked on the connecting rod, connected that to the piston, and went ahead and installed it using a little engine break-in oil. And now we have the rings inside set at 120 degrees to each other. First ones are down here. The first compression rings down here, gap. The gap for the second compression is here. And the oil ring gaps are here and here. So that's kind of what it looks like.
This is a side cover that I cut up to check the clearance for the crank, cam, and counterbalance. So if you look here, this is the camshaft. The lobes are longer and they stay open for a longer duration. So you have to make sure they clear the crank. And if they don't, you grind off a little bit of the crank. So that is super important to check because you don't want them hitting.
Alright, so I did have to do a bit of clearancing here. If you look at the connecting rod and the counterbalance, the little dip stick here, little oil dipper, I cut a little piece out of the counterbalance. This is a counterbalance right here. Goes all the way back. Keeps the vibrations down at lower RPMs. If you're not going above 5,000, 5,500, keep the counterbalance in. It's good for you. So as you can see, I had to shave a little bit off of it with the Dremel. So the oil dipper here will clear the counterbalance. So luckily I was able to get the clearance just right without taking off too much material.
So this is the connecting rod with the connecting rod bolts barely clearing a windage tray. I actually am in the process of building another engine that has a longer stroke crankshaft and it contacts there, so you might need to clearance that sometimes. And just make sure your dots line up on your crank and your counterbalance, just like on your crank and your cam. So now I'm putting in a brand new crankcase cover gasket. It's a good idea to replace those whenever you pull the side cover, especially if the engine's pretty old. If you got a brand new engine, you could probably keep the same one. If they tear, you for sure want to replace them because you don't want to have oil leaking out. Then you torque them down to spec. Notice that I'm going opposite sides, torquing it down to whatever the manual said for foot-pounds or inch-pounds to make sure it all seats correctly, and you won't have any oil leaks if you do use a torque wrench. So this head gasket is a stock head gasket at 50 thousandths of an inch thick. This one right here is 16 thousandths of an inch thick. It increases the compression ratio a tiny bit. Also, it's a very good idea to anneal it. I found out the hard way, and I'm actually not using this one, but if you anneal it first and spray it with gasket, you should be good.
Well, I finished cleaning the carbon off of the head, pulled the old plug, and I lapped the valves. You can see here there's a little gray ring around each seat where the valves are going. You want to make sure that that is perfectly clean, and there's a little gray band on the valves as well. These valves really didn't need it, but I decided to go ahead and do it anyway, just to be certain that we got the best possible seal for these valves.
So next here is installing the head gasket. It is super easy to do. Once you remove the head, there's 4 bolts to remove the head with, and the head gasket just pops right on top of it. It has these 2 studs at the top that actually hold it in place, so you don't have to worry about aligning it just right. You just put it right on top and then put the head on top of the block. This is a little piece of wire and a degree wheel, and we'll be using that in conjunction with a piston stop to determine what top dead center is with the head on. I'm using a little bit of thread locking compound here. That's just to keep the bolt inside from rotating or moving a little bit. So basically, in a nutshell, you rotate your engine by hand clockwise, then counterclockwise, and you get both measurements, divide them by 2, and that's what you need to set your degree wheel to determine where top dead center is. Alright, so we have 21.5, and that's the degrees. Then we also have 16.5. Okay, so if you add those together, you get 38 degrees. Okay, so 38 degrees of travel from piston stop counterclockwise to piston stop clockwise. Okay, so you just divide that by 2 to get 19 degrees. So then you reset your timing marker that you have with your wire, or you can rotate your degree wheel if you have your degree wheel on kind of loose. Either way, whatever you come up with, when you add these 2 together, you divide it by 2, and that equals the degree number that it needs to stop on, both clockwise and counterclockwise, and that will give you top dead center. So, what's the moral of the story? Who knows? 19 degrees. Whew. 19 degrees. Alright, so I pulled out my piston stop, and then this right here. Ooh, top dead center. Perfectly accurate. Dead on. Straight from the technical service manual, we're looking at coil gap set to 0.4 millimeters. Alright, so we've got 0.016 inch feeler gauge, which is roughly 0.4 millimeters. I've got the feeler gauge under there, and all you really have to do is just make sure it's not on the magnet. You just want it on the actual flywheel like it says in the user's manual. I know it's easier to stick it directly on the magnet, but we're going to go with how the user's manual has it. And you just basically snug up these 2 little bolts. You don't want to over torque it. You know, if you're a little bit anal about it, you can use your torque wrench here, but I'm going to remove it later, so I don't really care. And eventually we'll get this thing out of there. That was a funny little noise. Anyway, so there you go. That's how you gap your coil. Before top dead center is right about here where the spark is. Okay, so we're setting it right at 25, and then we'll look at the timing light to see what it actually fires at. Anyway, yeah. much better. Alright, so looking here, I have my timing mark where exactly it was firing right here, not what I expected it to be, but actually where it was firing right here, set. And if you look here, we're looking at 22.5 degrees before top dead center. I thought it was gonna be firing at 25, so that's kind of news to me. I'm using the coil that came with the engine. It's not a UT2 coil or anything like that. It's just got the regular, you know, kill switch wire and whatever else wire. So interesting. I go ahead and take the flywheel off. If I can get everything lined up just right. Shouldn't be that hard. I don't like tapping the flywheel. I'd rather just use the right tool and not worry about damaging it. There you go. Just use some channel locks. Alright, we are going to lap the flywheel to the crank here, because friction actually holds the flywheel to the crank, not the key. The key is just there when they put it in the factory to line it all up, and just as a reference if you need to pull your flywheel. Again, friction holds the flywheel to the crank, because it's very important to torque the flywheel down to the actual crank with the flywheel key not installed, because you're going to actually move the flywheel in relation to the key that's not there anymore. So that's why this mark is important to have on there. So you can see right there it's kind of gray, and it means everything was rubbing up against each other, which you want to see. And just going to clean it up, and then we'll move on to the next step. Now a lot of you are going to be wondering, whoa, why are you using that stock flywheel? I thought they fly apart. You know, if you're going to do any performance mods, you need to make sure you get yourself a billet flywheel, right? I'm going to say right now, you know, let me know in the comments below, but do you really need one? Yes, you do really need one when you rev to a very high RPM. I'm not going to tell you what it is, but for me, I feel comfortable saving 100, 150 bucks and running the stock flywheel, genuine Honda by the way, when I'm around 6,000 RPMs or less. Okay? The reason being is these genuine Honda flywheels have pretty good quality to them, and they're fairly well balanced. And I'm also keeping the stock counterbalance in there, so that's going to help with vibrations because I'm not revving super high. This engine is actually built for torque, and again, between 2,000 and 5,000 RPMs are when the torque is going to be the best, actually a lot better than stock. So with this flywheel, inspecting it for cracks, because they do fly apart if they got cracks in them, you typically see that, very rarely, but you typically see that with the clones. Since this is genuine Honda, it has a lot better quality control, a lot better casting, and I'm not worried about it flying apart because I'm not revving it too high. Okay, so this flywheel has now rotated this way in relation to the crank and in relation to the key, okay? So looking back over here, we're going to double check it, and we are pretty much right at 26. So I've got the stock emulsion tube here. I cleaned it out a little bit, and then I'm using a number 41 jet. That's 0.041 inches in the diameter in the hole here. Oh man, my thumb is shaking. Anyway, we'll start out with that and see what it runs at. We'll do a plug reading, but I think that should be good for engine break-in. So that's the emulsion tube, which is held in place by the jet. Just take a flathead screwdriver with the head that is thin enough, hook it up on the jet, and it just screws right in there. Pretty easy to install. So now that I have all of the short block cleaned out, all the internals torqued down to spec, and the side cover on, I'm going to go ahead and add break-in oil.
Alright, so I fabbed up this little plate, cut 4 holes in it, and then one in the center. I'm going to put another steel plate right here and weld it so it'll sit right in the keyway, and that will prevent the shaft from rotating, and I'm going to torque down the flywheel nut to spec.
So when you're torquing your flywheel nut down, depending on what engine you have, you need to look at your user's manual and torque it to the max recommended for stock. In my case, we're looking around 87 foot-pounds, and you need to do this with a torque wrench. You can't really just use a little wrench and hand tighten it, or you could spin your flywheel. Again, it's the friction that holds it on, and it must be torqued down to spec.
Alright, so one small issue I ran into here is, this is actually, before I get into that, this is a throttle stop and a circlip here. This is just the stock Honda part here. Anyway, so I've got extras of those, it's not a big deal. But if you look here, since I did remove the governor completely from the inside, some of you are going to say, yeah right, this is the governor arm, yeah, whatever. It's going to hit the cam or crank or whatever. Not true. I actually had that cut off. So the stock governor arm, the part that actually this part rotates on right here, is all in there. And I like that because I'm able to use the stock throttle mechanism here. So what is stock? So from here all the way to here is stock. However, the original holes were right there. Okay, so the original holes are right there. I just drilled 2 no holes right here. Okay, that's stock. Except for the part that goes into the engine that was cut off. And then I welded, if you can see right here, I did weld a little bit. I TIG welded this part of the new arm, I guess, that the governor spring was attached to. Okay, if you look, I'm not sure of the distance, but the distance between here and here, the pivot point here and here is roughly the same. Okay, it's not exact, but I just kind of played around with it until I figured it out. And then if you look here, this is the stock throttle stop, okay? But that's now taken up by this arm here. So rather than running the throttle arm right through here and having it connect here, so when I pull on the throttle, it brings it in, what I'm going to do is I'm going to relocate this bracket. And I'm actually going to have to get a new screw because this is stripped out. I'm going to relocate this bracket right over here because lo and behold, the exact same mechanism and hole and everything is built right there, because you can run a throttle through this way or through this way, and I'm just going to put the throttle stop right over here.
Ooh, hot. So what I'm doing here is creating the exhaust flange for my header. I'm actually doing a custom header. The dimensions, this is for a Honda GX390 by the way. The dimensions for the exhaust are about 1 inch for the exhaust port on the head. So I matched it to the exact dimensions of the exhaust port. Some people were like, oh yeah, let's do like a really big exhaust, it'll sound really nice, but actually if you do exhaust diameter that's too large, it reduces the scavenging effect and it kills your torque. So I matched it to the exhaust port so I can have high velocity and maintain my low end torque and keeping it long here. So what you see here is a frame modification. The intake side where the air filter goes, since it pokes out, was going to hit the roll cage, or what little, whatever that thing is. It's not really a roll cage, brush guard, whatever. So I wanted to keep that, and I bent a little bit of tubing and notched it with my angle grinder, and I'm just adding these little inserts here. and you know, just making it look a little bit nice while still retaining the frame and still allowing everything to fit. So after I took a lot of the paint off with the angle grinder, I went ahead and added some primer to the frame and let it dry. Hit it with the heat gun a little bit. I think I let it dry for about an hour, and then I hit it with a little bit of black engine paint. That's pretty much all the paint that I had that was black. Now this is one thing that is kind of my pet peeve. I see a lot of people add like a high flow intake, high flow exhaust, rejet, and then they just slap that air filter on there. And it needs air filter oil, because if you don't put air filter oil on your high flow air filter, you're going to have problems with dust. If you're going to be riding your go-kart in a really dusty environment or a really wet environment, putting on a pre-filter is the way to go. I prefer doing this on all my builds because I take them off-road. So this is my first engine start. It starts right up on the first pull. Just had to adjust the idle a tiny bit, but if you hear that little chirping sound, that is not normal. That's usually an exhaust leak. I actually thought it was an exhaust leak, but it's still chirping, so blown head gasket. So keep this in mind. If you get a thinner head gasket, you want to make sure the mating surfaces on the head and block are perfectly flat. I really didn't mess with that, but in addition to that, I found out that you actually need to anneal a copper head gasket, which is basically heating it up really, really hot till it glows and then cooling it down on a flat, cold piece of steel, and that will make it more malleable. I didn't want to jack with that, so I put the stock head gasket back in there for stock compression ratio, torqued it all down to spec again, and set my valve lash. Now, if you're curious on what you need to set your own valve lash to, it's specified on your cam card. So if you get a performance cam, read the cam card. It lets you know intake, exhaust, and timing. And then this vent tube, I'm just letting it go to atmosphere. With this off-road light, it's pretty straightforward installation. 2 wires. One goes to the red through a switch, so you turn the switch on and off, and the other one goes to ground, which you typically have as your go-kart frame. So I've always wanted to have a brake light on my go-kart, and I've looked into it a little bit, and if you have like hydraulic brakes, you can make it happen. And then I was trying to figure out how exactly I was going to do it, because I have actually like a mechanical disc caliper. So what I'm ending up doing here is fabricating a little bracket that will hold what's called like a universal brake switch, okay? And that brake switch is basically 2 wires coming into something. You can see it right here, that little spring, and then you put a little bolt on it or some way to attach it to something that moves. Okay, so the bracket stays still, the other part moves, and when it moves, it makes a connection to complete the circuit for your brake light.
Where's the button?
Is that bright?
Yes. I can't see.
Uh-oh, turn it on.
Now I can. Now I can. Now I can. I can't see anything. Okay, I'll turn it back on.
Whoa!
These are the wrenches that we...
Are you going to help me fix the go-kart with those wrenches?
Yes. Yeah, it fits.
Oh, it does? Okay.
Oh, maybe it doesn't.
Okay.
Now it's better.
Yep. Perfect. All done. Thanks. Thanks for helping me.
Now another one's.
Thanks for helping me. We're all done.
Oh.
And what that does is it'll kind of hold everything in place. That'll keep the throttle cable from stretching out funny when you have to curve it around the engine when you hook it up to the throttle plate. Get the throttle cable hooked up in there through your throttle stop. I've got the throttle hooked up over here, and that cable connects right here to the tachometer that I've got hooked up to the steering wheel. Okay, so it's zip tied down through here, get it wrapped around, and it comes up under here. I actually had to solder an additional piece on right here because the tachometer wire wasn't long enough. It's 2 wires there, and I have it coming right up to here, wrapped around about 4 or 5 times, about 4 times here, and then tied off here with a zip tie. This connects to this mechanical switch. Basically, when you pull on the brake lever here, it pulls a spring out of this mechanical switch, okay? So pulling on the brake lever, pulls on that switch, okay? Anyway, that hot goes to the battery, so it completes the circuit.
Crossing my fingers here. Oh yeah, there we go. Brake light. Woo-hoo. All right. So after figuring out that I needed a .043 jet, after reading my plug, I went ahead and installed that and did engine break-in. Basically 3 cycles of 2,000 RPMs at 10 minutes each, then riding it around, really gunning it to seat those rings in there after I got everything worked in with those 3 10-minute cycles. Now I'm changing the oil out. See all this metal in there? That is why you want to change your oil out after you break your engine in. I flushed out the engine with some additional oil. Alright, so now that I have the rings pretty much seated, I'm going to be putting in this zinc phosphorus fortified synthetic 5W30 oil from Royal Purple. I like it because it provides the benefits of synthetic oil with reduced friction and whatnot. And it also has the ZDDP in it, so that protects the lifters and the cam lobes from wearing down prematurely. So if that wasn't there, that could be an issue. And if you get like a crazy wild cam with super high lift where you need dual valve springs and whatnot, you know, you really need to have something with ZDDP in it if you want your cam and your lifters to stay intact, you know. So yeah, that's just a preference. You can put whatever you want in there. It's just super important to do ZDDP when you're breaking it in. I like having just a little bit of extra protection while I'm running it, even after break-in.
Okay, so my uncle just picked me up and it just finished raining, and now we're gonna go find some spots to ride the go-kart. Bring Landis, Grant, my other uncle Tim.
Need lots of electrolytes when you're going go-karting, right?
Yeah.
We gotta add a little oil to the mini bike. It's a little low.
Holy cow, could you get in closer? That full?
Yeah, you know it's full when it comes out, right? You're a little bit wet, dude.
I know.
Just saying. Just a little tiny bit.
I didn't know how much power this had.
Look what you did over here.
I didn't know it was gonna have that much power.
Oh, really? Yeah, before it could wheelie, now we add all these modifications to it, and you didn't know it's gonna have more power?
Not that much.
That's a cool little frog. He's probably gonna pee on you. He probably already peed on you.
Oh, you little turd.
The star's pretty grody. You just killed it, Colin. Oh.
That was the powerful one. Now I'm gonna have to.
Bah! Hunter killed it.
See?
Hunter killed it.
Struggle is real. What a shame.
Thanks everyone for watching this video. If you like it, please give it a thumbs up. It helps me out a ton. Also, let me know in the comments if you have any performance mods, questions. I usually get back to you pretty quickly. And finally, if you do enjoy this build and you want to see a lot more builds like this, it does take a lot of money and a lot of time to get this going. So if you feel free, like chipping in a few bucks, feel free to donate. I've left a link in the description for that. You can donate through PayPal on my website. So I'd appreciate it if you do that. If not, the videos are always free, and we'll see you in the next one. Here goes nothing. Oh, come on. Freaking A. I'm an idiot. I'm an idiot. Yeah, just burn out.